I am Charles. I'm the Mac nerd here at Enable. This is my contact information. You can DM me on Twitter or email me directly, charles.mangan@enable.com. Our agenda for today, we're going to be getting through answering some of the questions about why and how to use automation, what situations are good for automating and for creating those scripts, as well as creating policies and AMPs, which is for those of you who have not used Automation Manager, that is the type of file that we use that comes out of the Automation Manager. And then touching a little bit on using your own PowerShell within those AMPs. So if you are a PowerShell user, if you write your own scripts, that would be more for you. And then as well, getting down into troubleshooting and best practices. Why we're here. So if you don't already know the value of automation and how it can make your life easier, then hopefully by the end of the session today or part 2, you will have a much better idea. We will give you a little push to get started with how what you can automate and when to apply the things that we learned today. Eventually, we'll take the training wheels off, but you'll need to know your best way to get around. So best practices to follow when you're writing your policies. And all of this is toward the goal of being better and more efficient to get more work done with less effort. And so why is automation important to specifically to MSPs and to IT? So why do we do it? We get more done with less effort, as I said, ideally, and that improved efficiency leads to well, better margins and better profits for the business. Customers will get the same or better experience. Their machines keep working, and obviously that's why they pay the MSP. But you don't have to go around and flip the switches and push the buttons by hand. Anytime there's a person sitting at the keyboard typing in commands, there is potential for making mistakes. And that's why so many apps have an undo command. When a task is automated, you only have to get it right the one time. Then the machine will continue to do it exactly the same way, a million times forever and ever. Even at 3 a.m. when you're asleep or sipping margaritas on a beach that's 3 time zones away, you don't have to worry about making a mistake while typing because the computer's doing that for you. So all that tedious, repetitive maintenance work that you spend, even if it's just a few minutes a day here and there, it's important to keep up with, sure, but it's kind of mind-numbing and really distracts you from the more interesting stuff that the computer can't do on its own. Things like troubleshooting, marketing and sales, mixing margaritas on the beach, that sort of thing. The computer is happy to chug away and do whatever you've told it to do. And so that means the result is predictable and a nice standard level of service. It doesn't depend on which tech is handling the call or how much experience they have or how much time they have in doing a task. If the automation is written correctly the first time, all they have to do is basically trigger that. They don't have to know all the ins and outs of what the automation, of what your script is actually doing. And as more of those maintenance tasks are automated tasks, then you can set the timing and frequency of them so that they fall in line with your service agreements. So if you sell your customers on doing those health checks every week, then all you have to do is set those tasks up to happen every week or every day. Since you're not having to go through the motions for every machine each time, you can actually improve on your SLA. So deliver better service with the same or even less effort on your part than before, which full circle back to more efficiency and thus more profits. Now, some people hear automation and then envision themselves being replaced by a robot. Are your techs going to automate themselves out of a job? No. Think of it more as a force multiplier. If you can do more stuff in a day, then you are a more valuable employee, and the company can then charge more for your time. So the techs that go through and research and learn and build their own automations, write their own scripts to solve their problems, and then fix things for the other techs, those are the those are the technicians that get promoted and obviously are more valuable to the company. So when you're first bringing on a customer and their network, their endpoints, onboarding all of their devices, you can automate a good deal of that process. You know, we have agents that'll crawl through the network and find out which ports are open, what machines are there, attached to, detecting switches and routers and so on. And once they're all in the inventory, a few clicks, and you're deploying the management agent. And then immediately it starts gathering data on each of those endpoints. And then with that knowledge, you craft your policies to monitor what you know is there and how it should behave, and then notify you when things aren't behaving correctly. So that sort of constant monitoring leads to managing, i.e. making sure all the software is up to date, the data is backed up, keeping on top of malware and other security threats. And then if something does go wrong, if you do it correctly, then you get more than just a notification that some resource is offline. You can actually get notifications that your scripts have already rebooted the affected hardware, and then everything is all green check marks again. Monitoring and management is really where you earn your keep, but reporting is where you justify charging the rates that you charge. So just like in algebra, you need to show your work. What would have happened at your customer, their data, their hardware, or their business even, if you weren't monitoring and fixing things quietly in the background? What information can you glean from that data to then predict what's happening next? And so that's where the reporting step is very important. The point is that all of these different steps, all throughout the process, can be at least partly automated. So hopefully everyone's on board with why you would want to automate whatever it is that you can. And so now let's get into the how. There's any number of places you can fit automation into your normal workflow, but in general, it'll be in one of these three categories. An issue comes in that you've tackled 100 times before, so you already know what steps to take. Can't get your email. Do you have these three symptoms? Well, okay, I know what's wrong, and I have a script that will fix that for you. So that's reactive automation. And then there's self-healing. So the print server's queue is stopped because, oh no, its hard drive is full again. Or the monitor sees the error. Since it's one of the error codes you're familiar with, it runs a process to clear the cache and restart the queue. So all good, and back to printing. So that's self-healing. Only the printing doesn't even have to stop, because you can have a script in place that clears out the drive's cache when the monitoring agent says the drive is down to about 10% capacity. And then so from your reporting, you can see this kind of thing that happens every couple of weeks. So why not go ahead and run that script once a week and then trigger in case the drive is full. And so that is a case of proactive maintenance. So you can tell what's going on here, right? Cool. All right, I'll move on. I'm just kidding. This is a fairly complex slide, but it does give you a decent overview of the decisions that you have to make as you decide what issues you have that can be relegated to something like self-healing automation and what needs to be addressed by a human. So start with the PSA and reviewing your tickets. um, if the issue that's in that ticket is something that you're handling with a monitor, then yes, it's something that's monitored. If it's something that is a regular problem, then as the monitor comes up with a potential failure, then you can apply some kind of self-healing. So again, in the example of the hard drive getting full, we know that when the hard drive is approaching full, we can go ahead and delete the cache or empty out those temporary files, that sort of thing. So can it be self-healed? So in that case, yes, we know that the drive slowly getting full is something that we can take care of. So we have the root cause, and then we can create the self-healing task of emptying out that drive or emptying out those temporary files, that sort of thing. And so configured it, added in that self-healing option, and then on to the next ticket. So if it's a ticket that actually requires some troubleshooting, something that's something that's not not part of what you're monitoring right now, then that that becomes a thing that you pass on to an actual human to take care of, and so on. So the opportunity with each ticket that comes in to then decide whether it's something that you can automate the solution for or assign a person to actually troubleshoot it. And eventually, all the tickets that you get in will be ones that require human intervention, and all the reports that you get back of self-healing tasks will have taken a bunch of tickets off of your plate. So again, it's kind of a convoluted workflow here, but the general idea is look for what can be automated based on the tickets that you're getting in. So, so that is the, that's sort of the general idea of how to set up self-healing. So some typical examples, I've mentioned when a hard drive fills up, or when one of your checks reports the drive has reached its preset threshold, it triggers the the cleanup routine, deleting caches, temporary files. If your user has their hard drive is filled up with kitten pictures, you're not going to want to automate deleting those. I mean, you could, but then you have an angry kitten fan on your hands, and the same with the Hippocratic Oath, we should first do no harm. So the automatic cleanup threshold is maybe 90%. So if things are getting tight, you should probably give the user a warning maybe at 75 or 80, and then the option to run the cleanup on their own. And I'll show you how to do that in a moment. Or maybe you've got a server that occasionally drops out, service freezes up. That's a pretty easy fix. You can just restart that service, get on with your life. But if that service is consistently failing, you'll want some kind of trigger that gives you an alert if it's had to be restarted. So figure out why it happens more than once or twice in a row. And then on the opposite front, maybe you have a service or an app that you don't want people running. So downloading movies, from BitTorrent, or mining cryptocurrency, that sort of thing. If the agent, the RMM agent, sees a process name that matches a list of unapproved apps, it'll kill the process. Poof, done. But maybe it'll pop up a little nastygram to the user on their first offense. So, and again, if it keeps happening, you'll want an alert to see if it's being launched by, an obstinate user, or maybe it's malware. So quick demo of a self-healing policy. So let me go ahead and create a new policy here. All right. So what we'll do, what we're going to do here is create a prompt like we did before that will say something along the lines of, your hard drive is getting full. Run disk maintenance, and then we'll give it, maybe a 10-minute timeout, and then we'll do the buttons yes or no. Can we run disk maintenance now? Yes or no? And then that by itself isn't going to do much other than pop up the dialog. So what we want is instead, we'll take this if else block. So the output from the prompt, so is the click result, that's going to be the button that they clicked on. If the click result is yes, then what do we do if they click yes? So if they clicked yes, there are a bunch of maintenance. Let's see here, might be under disk. Yeah. I don't think we want disk defragmenting, but we can do cleanup. Yeah, here we go. Okay, so this object here, the clean manager, is there we go. Okay, so this object has a bunch of options in it for cleaning up temporary files and thumbnails and all that kind of stuff. So we can just go ahead and check all of these boxes. And so if the user has clicked yes, then it runs this cleanup manager. And then what do we do if the user has clicked no, or if the dialog box is timed out? So in that case, we want to add something to the log that says user has declined. And so if we zoom out here, you can see the workflow is, it's a little tiny text here, but we start out with creating the dialog box. And then if the user says yes, then does the maintenance. And if the user says no, then it adds something to the log files to say that they have declined the declined that dialog. And now we have an automation policy that we can apply. Save that. And I'll just put that on my desktop once again. And the way that we would apply that is on a machine that has a disk space check, for instance. If we assign a task after the check is done, so assigning a task to react when this threshold gets to 20%. And so now this automated task, and what we can do is, our disk cleanup task. So what will happen is when this check fails, which is to say the disk space gets below a certain threshold, then the disk cleanup task that we just created will be triggered automatically. So it's a self-healing proactive maintenance step. So if you are taking and applying this disk cleanup task to check that is on this particular machine, it is not going to be applying that same task to other machines with that same check. So what you would need to do in that case is apply that to the template. So if I go into my manage templates here, let's see here. Let's go ahead and apply this. So in this case, I would add that disk space check here, get it down to, say 15 gigabytes, I think was your example. Okay, and then if I want to add a task, I can add my cleanup task or whatever I wanted to add here, and do do all the actions here and set it as a check failure. And so when the disk space check on drive C fails, so now I have that disk space check and cleanup temp files, or the AMP that you've created as a task in a monitoring template. So I can either have that template and then apply it to all the workstations that I want to add that, that same reactive task to, or I can go in and do that modification to one of the existing templates that that is applied to this machine. So if I go into workstation here, I should be able to see what templates it has applied to it. Of course, I'm blanking on where that information is, but in any case, so I can see, so you can see that you can either apply that to one machine at a time, or when you're creating or modifying the template that is applied to that machine. So as far as the automation, the scripts and policies that you're creating, they should produce some kind of output so that you know they ran. Like in my earlier example, adding something to the log file that you'll be able to look for in the output. The user should see something like this in that previous example, and then when it runs, you see the output it produces in here, and then you can see things like when it ran, whether the user agreed, and so on. So so it's, yeah, it'd be in here. Of course, the screenshot does not include that, but that output is also captured in a log file, which is just a plain text file with that same information in it. So they clicked on yes, and then it actually went through and did the delete temporary files, and then did all that, and send the output parameters. The result is, in this case, 0, which is actually a good thing, because what that means is there were no errors. So an exit code of 0 or a result of 0 is generally a good thing, and a result of something that is not 0 usually means that there was some kind of error, and that's when you look up that error code. That log file, that text file, is suitable for doing troubleshooting, or if you're collecting a bunch of them at once, you can then search through them with some kind of analysis tool. If you need to find if you've got 1,000 machines that are all running this the same script, and they all have slightly different output, or you've got a few that are failing and a few that are not, then the good news is that you have a log of all that activity. So now we're on to proactive maintenance. So another flow chart. Get used to these, unfortunately. So once you've worked with a customer for a while, you should have a good idea of what tasks that you are regularly doing, and some idea of how often. It may even be detailed in the scope of work when you onboard that client for the first time. So once you have that checklist, then you can start doing those maintenance tasks proactively instead of waiting for things to react to. So if you don't have a checklist already, I would suggest you create one by reviewing your help desk tickets. Things that are frequent tasks, those are good fodder for an automation policy. So, and you really shouldn't have to start from scratch. Every customer, of course, is a different and unique snowflake, but they're all generally running one of a handful of operating systems, fairly common applications, fairly common hardware platforms. And so there's no need to reinvent the wheel when it comes to common maintenance tasks, which is why RMM has a library of pre-built wheels, so to speak, as a starting point. And of course, we're always adding in more. And to that end, we have what we call the automation cookbook. So on our website under success.n-able.com/cookbooks is the automation cookbook. And as I said, we're always adding in new things and new scripts, new policies in here that you can grab and use for your own. So let's take a look at maintenance scripts. So if you can't find the specific, something that covers your specific need, and you do end up creating it on your own, then you can submit that to us, and we might add yours to the cookbook, share it with the community, and that way the community benefits. So there is you can log into upload a script here, or if you have not created your own, but you have an idea for one, or you have a suggestion for one, that would be where you go to the community ideas. And so create a post in the ideas forum and ask about, is it possible to do this and that? Is it something that would be beneficial to be able to monitor? And the answer is usually yes, and we can help you with creating that. Obviously, the the kinds of things that you are running into may be unique to you, but very often they're going to be common to other people in the community as well. So getting back to our proactive maintenance flowchart. So you have your reviews, you have your tickets, and you've gone through and reviewed the kinds of things that you're regularly doing for that customer. And so making a checklist and deciding what can be automated. Here is an example checklist of tasks for, say, database maintenance, starting with things like opening up the logs and see what kind of errors there were. And then all the way down to when were the antivirus definitions updated last? You know, how big is the transactions log? Did the backups run? That sort of thing. Each of those is something you can be, you know, paying your DBA to spend time on each day. Hopefully not at a super high DBA's rate, or you can handle it with a handful of scripts and policies. So each of these checklist items can be replaced by check the proactive maintenance notifications. If none, then continue making your coffee. So for instance, is the application log filling up with events? Doesn't need a human eye to look at. That's just a monitor of a monitor of that log to see if the threshold is reached above a certain point, or if it is matches certain error codes or what have you. And if it doesn't, then you move on with your life. And the rest of these items are pretty much the same way. So how large is the transaction log? Did the backups run? Those are all things that don't require a human to verify each day, or even multiple times a day. Some of the typical proactive tasks that you can put into place, things you usually have, set yourself a reminder to do, or oh, it's Monday, I need to do that thing. The server had a software update, for instance, that required a reboot, and now that it's rebooted, nobody can connect. Oh yeah, that process needs to be kicked off each time there's an update. So write a policy, write a script. How long has it been since it rebooted? If it's less than a certain amount of time, is the process running? No, well then start it up automatically. If you're looking for trends in error messages, things, notifications that you get. So is the log file growing faster than it usually does? Was there a jump in the number of errors compared to the last time that automation ran? You can save that information, refer back to it, do a little basic math. I promise it's basic math, not too complicated. If your trend is over a certain threshold, then create a ticket. Send out a message that it looks like something's up, and then you get your, then you can actually spend human time looking into and troubleshooting it. And if you're spending time looking through the latest patches from Microsoft or various software vendors, approving all the critical ones right away, putting the less critical ones into the queue for later, that can easily be handled again with a policy. So that way you get the security updates as soon as they're available, but wait a little bit for the less crucial ones, saving the user that update fatigue. And then of course yourself from having to roll back an update that gets pulled because it came out half-baked, which does happen from time to time. You get something that comes out on a Tuesday and gets rolled back on a Wednesday, and if you've already applied it, then you have to roll it back on Thursday. So our next demo is going to be let's see, let's create a new policy. What we're going to do is kickstart printer. So what happens is the print server reboots, and then for whatever reason the print spooler service needs to be restarted manually after the reboot is done. And so this is how we would do that. And of course, you can replace print spooler with database server or web server or whatever works, whatever is applicable in your environment. If there's something that is working or in this case, not working in the same way. So what I will do then is, let's see, I will look for the service, but I will see if the service is running first. So I don't want to start up a service that's already running. So is service running? There we go. And then what I'll often need to do, instead of just using one of the defaults here, is figure out what the name of the actual service is. The display name and service name can often be slightly different. So let's here go to services, and let's look for print spooler. So print spooler, not a big deal. That's going to be fairly common regardless of the localization. But if you're doing something that is a custom service, or if you're using a third party, something that's installed, it might have a name that is slightly different from one of the default ones. And if you're doing something that needs to restart that service, it is going to be specific to that service name. So, which brings us back to the case-sensitive question. So some of the service names are going to be localized based on what language the machine is set to run and that sort of thing. So what you'll do is you'll grab the name of the service if it's not something that's one of the standard ones. In this case, it is spooler in our example. So is this is the print spooler service running? And so I'm going to get either a yes or a no. So in that case, I need to get an sorry, if else. So the input for my if else statement here is going to be the result of this is service running block. And then the output from that block is the conditional, which is the output from this block returns true if the service is running, otherwise false. So I know that it is going to come back with either true or false. And what I want to see is that condition equals true. And so if it does equal true, so the print spooler is running, then really we don't need to do much of anything. If it's not running, well, then we can restart it. But it may be that the machine itself is in the process of rebooting. So what we'll do instead is check to see if another service is running that we know the machine has rebooted at that point. So often we will look for the Windows time service, which we know that this service will be running once the machine is online and has been able to check in with its the NTP server and it's synced up and everything. So if the Windows time service is running, then we know the machine is running. And we can safely start up the print spooler and know that the then we will know that the machine itself is ready to print. So since the time service is one of the last things that actually starts running when the machine is ready to go. What we'll do is check for that. And then this is an example of, well, which one of those is service running blocks am I checking? So cancel that. And this is where I need to rename some of these blocks. So is time service running. And now I can see, is the time service running? The output from that is either true or false. And so if I want to equal true, so if the time service is running, then now I can start the print service. And I want to set it up, yeah, so I just want to leave it as starting up the service name. So the service is running. So if the print spooler is running, then I don't need to do anything. But if it's not running, then I will check to see if the Windows time service is running. And if the Windows time service is running, then so that means the machine is rebooted and ready to go. And so it should be ready to print. So I'm going to start up the print service, and then we're going to give it, let's say, 60 seconds. And then we will check again to see if that service is running. So basically checking to make sure that that print spooler fired up. And then again, if it is running at this point, then all is well, and we can move on with our lives. But if it's not, so service restarted, yeah, okay. And so we'll look for equals true. And so finally, if the print service has restarted, then what we can do is log no, I don't want to log off the users. That's not what I want. No, I want to delete that block. That's my delete key not working. Sorry, bear with me just a moment. There we go, delete. Okay, so I don't want to log off the users. I want to log to the log file. Success, yay. But if the print service fails to restart after 60 seconds, then I want to do something about it, but that may require human intervention, at which point I will say that automation policy has failed and it will trigger an alert in RMM. So to recap, I will check to see if the print service is running on that machine. And if it is, where's my then statement? Okay, so if it is running, then we can go ahead and either just ignore it or add in something into the logs, or we can change this from an if else to just an if then. So if it's not running, then do this thing, and we don't have to worry about the else. I always like to leave the else in there because that way I can have the conditions of, when I always have the choice of doing things when the condition is true and also when it's false. So so if the print service is not running, then we'll check to see if the time service is running. And if the time service is running, then we restart the print spooler, and then we wait 60 seconds to check to see if that print service has restarted. And if it is, then all is well. And if not, then we fail the policy. And then we can also go back to if the time service is not yet running, then wait 60 seconds and go on from there, and basically build all the different conditions and all the branches that we want to check. But otherwise, we will move on to reactive automation. And this is the last flow chart of the day. It seems a little counterintuitive to call an automation reactive, since typical use for automation are so you don't have to react to conditions. A script or policy will generally take care of that. But in this case, what we're looking at, what most people build when they start out in scripting, and that's repetitive fixes that can be reduced from a series of tasks into a script that runs with one click. So if you've ever worked at a help desk or a call center, you might have used a flip chart or a decision tree to navigate when a call comes in. Questions like, is the computer on? Yes. Are you logged into the computer? No. Can you log into the computer? No. Do you know your password? So on. If you can write a series of steps for a help desk tech or one of your end users to fix their own common problems, then you're halfway to writing a script to do it for them. So generally what I would say is find your most frequent offenders by running a report in your ticketing system. Who's having the most trouble? What are they having trouble with? Unfortunately, you can't fix, PEBCAC, and everybody that knows what that stands for, right? But for a lot of the common issues, you actually can automate your way out of the problem. So generally correlate that report with what's on your tickets and see what the most common issues are that your users are having. If it's something that takes 5 minutes to fix, but you're having to spend that same 5 minutes, with a dozen different users, 10 times a month, well, then automating it will save you easily an hour a month. So find that sort of low-hanging fruit. And if it's a common task that you're dealing with, you're likely not alone in dealing with it. Again, you don't have to reinvent the wheel. Have a look at the automation cookbook and see if there's an existing policy or script that you can download that can customize it maybe if you need to for your own situation. And then once you have, make sure you document that new solution so that all the other techs in your company can then take advantage as well. So next month, when you run those reports again, compare that time that you spent on that issue versus before, and the amount of time you spend before versus after having that script in place, and you should be able to see a difference. So some examples, obviously. Most common problem, oh, I forgot my password, or it expired, now I can't log in. So tech has to go into whatever system they're locked out of, check the box or click the button to reset the user's password, then set the user the reset link, unlock the account, and so on. Depending on the system and the kind of authentication that you're using, that can be a pain. It can also take several minutes for the change to sync up or for the email to arrive, and then you have to update the user to have them try it, so on. So if you see that ticket come in, all those steps can be put into a script. The tech clicks to run the script while getting the user's information, and then have them check, voila, the account's already unlocked, and you're a hero. So second most common problem, at least when everyone was in an office sharing a network printer, the second most common problem was I can't print. Well, if nobody can print, well, that's easy. Then generally restart the printer or the print server. If it's just one person, I'll then restart the print spooler on that user's machine, print a test page. If it works, then great. Again, you're the hero. And it was just one click in your dashboard to run that task. The last one, and I'm not sure why it's exactly an example of a reactive use case, since it's something you probably should be doing proactively, but sometimes your backups maybe take up too much space, or there's an error and it needs to be kickstarted to get going again. So you've got to log into that server, navigate to the folder that's 10 layers deep in the file system, select and delete the backup logs that are older than 30 days or whatever. Again, these are all tasks that can be ordered up via scripting. So let's take a look at how you might actually do that. So again, we'll create a new policy. And let's say this is, let's just call it folder cleanup, clean up folder. There we go. So first off, let's figure out what folder we're going to be working on, and then determine, does the folder exist? And how many files do we want to keep at minimum? So in this case, what we're going to do is put those values into input parameters. So what input parameters are, so normally if you have an object in Automation Manager, it will have certain inputs and certain outputs. So the input parameter, for instance, in this logging block is the message that you want to add to the log, and then it generates outputs of what was written to the log and whether or not the result was successful. Before you put any blocks into your policy, you can add in input parameters that get added at runtime. So let's say we want to figure out what folder we're going to be working with. So let's call this folder path. And oftentimes what we want to do is name our inputs in such a way that we can find them again later on in the script. So in this case, I'm starting with the word input or in, and then the path itself is a string. I can also have it be, a number or a date or an encrypted field for passwords, but generally we'll just leave it as a string. And in this case, we're going to look for // So that's the path to the folder that I'm looking for. It could be, a projects folder, it could be backups, it could be whatever. In this case, by default, it is going to be the temp folder. And let's take a look at how many files we want to keep in this, theoretical archive folder. So number of files. And since that's going to be a number, we want to make it a number. And let's make the value, let's say 10 by default. And then we'll add one more parameter here, and we'll say what kinds of files. So if we're working with archives, maybe they're zip files, maybe they're backup files, a .bak or whatever. So what we're going to do is call this input. We'll call that file mask. So again, it is a string. And for right now, we'll just do star.star as our value. So we're going to look for all files, regardless of their file type. And so these are the default values. When the script starts up, if I don't put anything in, they are going to be filled in with those default values, but it will ask me to override those when I start the script. So now those input parameters are in there. They're just quietly hiding under that input button. So we have to figure out if the folder that we're looking at exists. So we'll have a look at the folder exists object here, and the input for that block is looking for the path to the folder. And so look, I have in my input parameters a path to the folder. If the folder does exist, then great, then we can move forward. So I'll have my if then. And actually, let's take that and yeah, we'll just leave it as an if then. So if the folder does exist, great, conditional of equals true. So if the folder exists, then how many files are there in the folder that match our search terms? So it's going to be a folder file count object. So I'll take that, pop it in there. And so again, what folder am I looking at? I'm looking at the input parameter and its folder path. And then the filter in that object is looking for file mask. So in this case, the file mask is, again, from our input parameters. And so that is going to output a number of files in this object called file count. So again, do another if. So if, drop it in, oh, I can't drop it in there. Of course I can drop it in there. There we go. If, and then this time I'm going to take the output of the file count, and if it is, in this case, greater than my input parameter of number of files. Then now it's time to do some math. So what we need to do is figure out the number of files minus the number of files that we want to keep. So we'll do a little bit of basic math. And look, there are math operations right here. And so what we'll need to do is take the first number, which is the file count. And the second number is going to be our number of files. And then we will take that and subtract number 1 from number 0. And so we'll get a result of how many extra files there are. So that will give us a variable of how many files to delete. And generally what we're going to do is look for the oldest files and delete those. So we'll take the find top n oldest files object, and again, looking into our folder path for objects that match our file mask, and then looking for the result of our math. And so now we go all the way back up to the top. We're going to check and see if our folder that we're looking at, if it exists in the first place. And if it does, then we're going to count how many files are in that folder. And then if that number of files is greater than the number of files that we are hoping to keep in the folder, then it's going to do a little bit of math and then subtract and get the number of extra files that we want to get rid of, and then sort them by oldest. And now that it has found the top, say, however many oldest files, that will give us a list of files. And then with a list of items, what we can do is a for each. So for each of the items in this list, then what we can do is delete them. If I can spell delete correctly. So we can delete the file, or I think we can send the file to the recycle bin. So if we want to have that as something that can be reversed in case we do need to find it. So the result of the for each is a file name. And so the file name goes into the path to send to the recycle bin. And so if we go all the way back here and let's save that, and we'll do folder cleanup, we'll call it folder cleanup, it's great. So if we click run on this, first thing it's going to do is ask us for the parameters that we want to fill in. So it's filling in the default of temp and then 10 files and then the mask of star.star. But let's see if I have a, yeah, I've got some files in my downloads folder. And there we go, properties. And what I can do is copy that. And let's run this against that folder path with my downloads in it. And let's say I only want to keep the latest 3 files, and we'll hit OK. And it's going to run through. And let's see if I can expand this window up here. Okay, so if we go back to the beginning, you can see in the output that it is looking in this folder, and that folder does exist. Great, folder exists, and then it is going to look to see if there's more than 3 files in it, and there are, and so it's going to subtract the number of files from that 3, and then it's going to give me the 3 oldest files. And then for each of those files, it is going to move them to the recycle bin. So send file to recycle bin, send file to recycle bin. So now if I look in that downloads folder, oh, it had a problem with one of the files is probably an invisible file or something. But anyhow, it removed a couple of files from that downloads folder, and they're now in my recycle bin. If you log into success.enable.com, and if you haven't already, go ahead and register for the MSP Institute. There's a bunch of training, previous boot camps, documentation, and all sorts of other things there under that MSP Institute tab. And I'm not 100% certain, but there's probably a previous version of this webinar content there as well. Obviously, what we do today includes things like live Q&A, updates on the latest versions of things, but previous versions are recorded and often posted in the Institute. So that would be a way to do a recap or to go over something that you might have missed during today's session.